Farming mushrooms is very different from farming nearly any other kind of food, because of course mushrooms aren't plants or animals. The act of growing mushrooms looks and feels much more like growing bacteria in a lab. Fungi aren't bacteria either, they're their own kingdom of life. But the bacteria analogy holds inasmuch as a mushroom farm is much more laboratory than it is field. There is no field because mushrooms don't need light, at least not in the same way that plants do. They aren't photosynthesizing anything. They're not vegetables. Certainly lots of different kinds of mushrooms are cultivated lots of different ways by lots of different people. I'm just showing you one example today. Middle Georgia mushroom in Macon, Georgia. Hunter Pruett, his grandmothers, and his girlfriend Anna grow mostly oyster and lion's mane mushrooms for local restaurants.
We're bringing fresh gourmet mushrooms to Middle Georgia.
First step is to prepare a substrate, that is the substance on which the fungus will both grow and feed. It lives inside its food. Ain't that the dream? In the wild, mushrooms can grow in the ground, specifically ground that has lots of biological material in it, like old dead leaves. Or they can grow on dead trees, decaying wood. Hunter replicates the dead wood substrate by using sawdust pellets. These are usually a byproduct of sawmills. People use them as fuel for grills and smokers, even home heating stoves.
Once this stuff is hydrated, it turns into just the mushroom's paradise, right? Mushrooms in the wild grow on hardwood species, so we found out that these pellets work just as good as that.
Hardwoods are basically the trees that aren't pine-type trees. Conifers have that sticky, Christmas-smelling resin in them, which has antifungal properties. For that same reason, people don't usually cook with softwoods. They burn really dirty. You end up with food that's coated in this kind of bitter soot. So generally speaking, wood that is good for cooking can also be good mushroom substrate.
And what this is we've taken those pellets, we've put them in that bag, and we've put in a certain amount of water, and we let that water absorb in that pellet, and it comes out to this nice little block.
The problem, of course, is that block is probably full of rando microorganisms. Microorganisms that could grow in the very favorable conditions of Hunter's mushroom fruiting chamber. So
we bring it over, and we put it in this big old barrel. We call this our atmospheric steam sterilizer.
It's basically a big tank with a heating element at the bottom. Hunter loads the sealed bags in there and pasteurizes them at 204 Fahrenheit, 95 C for 18 hours.
What we're doing is just running steam up through the blocks, and it's just heating that block up to 200 degrees, which is going to kill all that competition, those competitive organisms.
The bags come out totally sterile, and then it's time to inoculate them with the fungus that you actually do want to grow in there. From here on out, everything has to be done in an ultra-sterile environment. The air is full of yeasts and molds and bacteria and other things that could outcompete Hunter's mushrooms in that substrate.
So there's one mold that mushrooms growers are just fighting every day, and that's trichoderma. It's your green mold, it's your common mold that you find on breads. It loves to eat the same kind of substrates as mushrooms.
So everything he does now, he will do while standing in front of this flow hood.
What this does is it pulls air from the back, pushes air forward, and then pushes through this HEPA filter.
Those jars he has sterilized in a pressure cooker. Everything else he's going to spray with isopropyl alcohol, cut with water, a 70% solution, so it doesn't evaporate too fast.
Kind of spray your hands down, spray your surface, spray your bag.
And here's what Hunter is starting from today, some mushroom culture that he has ordered. You can grow mushrooms from their spores, their seeds, or you can grow them from mycelium cultures, and the latter is generally regarded as the more reliable method. The mycelium is the main body of the fungus, these white filaments that grow inside the substrate. In that syringe, he has little bits of mycelium floating around in a sugar water solution that the mycelium can eat. And he's injecting it into jars with even more sugar water.
It's a 1-to-4 ratio of water and light corn syrup. So the mycelium actually grows on the sugars that are in the syrup. Go in the jar, we'll do about 2.5 milliliters.
What he's doing here is expanding the culture that he's ordered, putting it in an environment where it can rapidly grow so that it'll have lots more of it, and so it will last until he needs it. The other advantage of liquid culture is that the mycelium won't grow a mushroom in there. It has no structure to hold on to.
We have a little stir bar, and what that stir bar is just a magnet. We put it on the stir plate, and what that is going to break that mycelium up, that way it can spread throughout the jar.
Look at that magnet spin. Super cool way to stir something without potentially contaminating it.
And within 7 to 14 days, this jar is going to be fully colonized, similar to this.
That's the thing about growing fungus instead of plants. Everything happens way faster. Given the right conditions, mycelium can expand almost as fast as a brand new mattress from the sponsor of this video, Helix Sleep. Let me thank them. Helix is a premium mattress in a box company. I've been setting up our new house here, and it was awesome to get a real, very high quality king-size mattress in the mail. No movers necessary. They just shipped the box to me.
Whoops.
You break the airtight seal and it balloons like a mushroom. This is the second Helix mattress we've gotten because we love them. We've been sleeping on them for almost a year. They're tailored to our bodies and how we like to sleep. You take a quiz online, Helix helps you choose a model. Lauren likes really firm mattresses. My back does better when it can sink in a bit, and this mattress was the perfect compromise for us. Shipping is free and you get a 100-night sleep trial. If it's not working for you, Helix will come take it back and then you'll get a full refund. You can save up to $200 on your Helix Sleep mattress by following my link in the description. Or go straight to helixsleep.com/Ragusia. Save up to $200 and get 2 free pillows. Thank you, Helix. Now, check this out. Before Hunter can seed another jar with liquid culture, he's got to sterilize the needle. He's got to work clean.
We're going to turn our heat off, keep it in front of that hood, let it cool down, squirt a little out, cool it off, bring it in.
Now, before Hunter can grow mushrooms from his liquid cultures, he needs to test them first, and he does that on Petri dishes, little plates covered with agar-agar.
Call me Agar.
If there are contaminants in the culture, they will present themselves much more readily in the Petri dish. They'll be able to grow. And the mycelium can actually grow into a full-fledged fungus in there. So he's also looking to find particularly strong genetic specimens, groups of mycelium that are so good at growing and being alive that they are outcompeting other groups.
And you can see how there's no kind of synchronization with this mycelium. There's just groups growing everywhere, right? So what we do is we would find a very healthy looking group, like some of this rhizomorphic here, some of the edge of this, and we'd cut it and we'd transfer it to another dish. That way we can grow that good, strong isolation that we all hunt after. So if you can get one good genetic growing, you can multiply that genetic tenfold, and then that can be your genetic on your farm, that you know how it grows in a certain temperature, how long it takes to fruit, how long it colonizes. You know everything about that thing.
In contrast, look at this one. You can see that's not several different fungi all battling it out. That's one coherent organism that Hunter has successfully isolated. You can also clone a fungus you like by just chopping off a piece of the fruiting body, the actual mushroom there, and putting it in agar. Hunter does that too. Here's a clone of a lion's mane mushroom that actually started growing a new fruiting body inside the dish.
It's actually just a suffocating fruiting body. You can see that it's coming out and it's reaching for oxygen. So mushrooms are just like us. They actually they inhale oxygen and produce CO2. So they're closely related to us humans. And he's looking for some oxygen. That's why he's stretching out like that.
As we've discussed previously, fungi are actually closer to animals than they are to plants. I have a whole video about what exactly mushrooms are. It's linked in the description. Next step is for Hunter to use the genetic specimens he's isolated to inoculate jars of grain. Those are literally just whole grain oats in there. Pretty much any kind of seed works. Fungi like seeds basically for the same reason that you and I do. They're nutritious. Again, he's just expanding his culture, growing more of it, and making sure it's pure, that it hasn't been contaminated by some bread mold or something.
Everything's white. There is no different greens and blues and pinks.
The other great thing about starting your mycelium in grain is that it's granular. You now have lots and lots of tiny little bits of things that are individually seeded with your fungus.
The thing important to farmers is how many different vehicles of inoculation you have. You have probably, I don't know, 5,000, 6,000 kernels in this jar, and it's gonna get mixed into a big old bag of sawdust, and that grain's gonna be distributed through that sawdust.
So the grain spawn, that's what that's called. The grain spawn goes into the sterilized bags of wood pellets, and he lets the mycelium grow in there for a week or two.
But yeah, you can see this thing is fully colonized, ready to go. And then you'll just get you a sharp object, and you'll slit that bag right there. And from here, she'll go into the chamber. We'll place that block up, and somewhere around 14 days, she'll be fruiting some oysters.
That fruiting chamber is where the mycelium will grow an actual mushroom. It'll come up out of that slit in the bag. First, they come out as little dots like that. Those are called pins or pinheads. About a day later, they might look like that. Then it's off to the races.
This will be about that size tomorrow, and then it'll come in and it'll be about that size on day 3. They are insanely fast growers.
And over that time, Hunter has to watch his fruiting bodies and manipulate the environment of his fruiting chamber accordingly.
So mushrooms in the beginning stages like very high humidity, whereas mushrooms throughout their life as they start pinning require much more lower humidity.
You can see this for yourself out in your lawn. It rains, and then you see a bunch of mushrooms sprout when it's really humid, and then if the air doesn't clear, if it stays really wet or if it stays really stagnant, those mushrooms will rot really, really fast. Alternatively, if things get too hot and too dry, the mushrooms just shrivel up. They're like 90% water. So in general, they like really humid, somewhat dim conditions. That doesn't mean they don't like some light. Some mushroom species use light as a signal or a trigger for growth. The precise reasons and mechanism for this are things that are still being worked out by science.
What we found, and I believe this is probably debatable, is that mushrooms actually use sunlight as just a sense of direction that draws them towards oxygen. So if you think that, with all natural light occurring, the sun being the highest point, the organism knowing that, they say if I can get to the sun, then I can reach the oxygen.
And once the mushroom cluster is full grown, he's got to cut it off the block right away. The mushroom is the fungus's temporary reproductive appendage. Its job is to grow up tall really fast, cast the spores into the wind, and then just die back.
So you really got to pay attention to them, because if you let them get to a certain point when that cap starts to open up and those spores start to drop, this room's going to be a mess, man. Your fans are going to get clogged up, and your humidifier will get all nasty.
The lion's mane mushroom drops its spores from those little teeth. You can tell it's ready when they get long in the tooth.
This one right here is past its harvest prime, but I love the way this thing looks, man. It's still totally edible. So you can really see that this mushroom has this stringy, crab-like, barbecue pulled pork-like texture.
Once Hunter harvests the fruit cluster, he can grow another one from the same block. That's called a flush. He can generally get 3 flushes from a block, though they get progressively smaller and more susceptible to contamination from a random mold floating by.
The nutrients start to disperse in the block, so it doesn't have a lot of food. The army becomes weaker, right?
Can you tell Hunter is a veteran, all the combat metaphors?
When the army becomes weaker and a new fresh contamination comes in, that contamination's a lot of times gonna win, right? It's gonna take over that block, and it's gonna be able to make its little stronghold.
At that point, the block goes in the compost and the whole process starts again. He sells these inoculated blocks on his website. It's a kit that you can grow at home. I did that. There's a link in the description. A common trait that I've noticed among mushroom growers is they tend to be evangelists. They believe in the power of fungus. Its power to be a medicine, its power to be a sustainable protein source, even its power to filter pollutants out of the environment.
We want to turn this into a community thing. We want it to be a farm. We want this to expand into some land and to really grow the awareness for fungus right in our community.
Might sound grandiose, but I don't think it is. That lion's mane, for example, has been shown in mice studies to promote neurogenesis, the growth of new brain or other nerve cells. Hell, it even looks like a brain, and it's been shown to improve cognitive function in geriatric mice. Maybe it'll improve cognition in a geriatric me in a few decades. We'll see. In the meantime, I'm gonna keep eating them, thanks to the hard work of laboratory farmers like the folks at Middle Georgia Mushroom. Go get you some.